Yeah, so essentially what I'm going to mainly go through today is setting up, the environment and how to use Git. But essentially, in nearly all software development projects, you have a thing called Sdlc, so software development lifecycle. And with the waterfall methodology, you usually start from requirements, and then feasibility, and then design, coding, testing, installation, deployment, and maintenance. And if you're doing it in an agile method, it's essentially the reason why you would use agile is because you might not have all the requirements set out for you. And just think of agile as mini waterfalls for every single sprint. So it's iterative, and every single sprint that happens, you gain more requirements, and you do more design, you do more coding, and you do more testing, and then you deploy features of the code, or features of the software product that you're making. And you can create you might end up creating releases for every sprint or every milestone that you reach. But I'm not going to go through that into depth. What I'm mainly going to focus on is mainly the version control, the Git side of things. So firstly, I'll just read through over the dot points that I've made. So first, we would set up the environment, and I've created links just to make it easy for getting references. And I'll just talk about the high level theory of why Git is used and how it's usually used in the industry. So the main reason why Git is used was because there used to be a time where like the internet was fairly terrible and fairly slow, and it was difficult for developers to share code and work on code simultaneously. So what they would used to do would be that one person would write the code, and then they would put like a version stamp or a timestamp or whatever whatever naming standard they put on their piece of code. They would put that on the code, save it, and then if they wanted to get someone else to work on the code, they would copy that file, put it on a USB drive, and then give it to someone else. Or they would have a centralized storage space where people can access that storage, and they would copy that code, and then other developers would work on that code, and then they would put their own timestamps on it, or they would put their own convention of saying that they worked on this piece of code. And then when it got to a certain point where two different developers had two different versions of the code, they would just sit down together, and this is what you'd find in extreme programming, where you have pair programming, and they would sit down together, and then they would go through line by line to figure out, how do you combine line by line of code, and how do we make sure that there's no conflicts, or we fully test and make sure that there's no bugs in the code, right? So they do that, and then after that they have a final code, and then they deploy it on the servers, or they deploy it, or they test it first and then they deploy it. And that process would be fairly lengthy because there would be a lot of clashes in timelines and code, and it was just really messy. So it was out of necessity that people had to create version control, because they needed a way to sort of they needed a way for two developers to work on the code simultaneously while not interfering with each other's code or development. So
like management.
Yeah. So it's sort of like what I was showing you before with Jira. You've got individual issues for individual team members, and then they're assigned a different task, and they work on different tasks, and they don't have to go sit down in a physical room to figure out who's working on what, because it's all online. But that's what they used to do when they didn't used to have those tools. They used to have, like, say, meetings physically, and then they used to discuss, this person's working on this, and this person's working on that, and they would have like a board with sticky notes of putting names down and putting names on those sticky notes to say, oh, this person's working on this and the other person's working on that part, right? So I'll just go back to that Git branching. So Git itself, if you know the fundamentals of why it's used, becomes it becomes simple when you know how to use it. And that's obviously with everything else. When you know how to use it, it becomes simple, right? But when you're just looking at it, it's like, oh, wow, there's like a lot of commits. There's a lot of branches. It's all confusing, right?
Yeah.
So essentially, at first, people would just when they made versioning, people would just work on one branch, and it would just be like the master branch, and then still it was disorganized, because what if you had an extra feature that you wanted to implement on the side, right? And you wanted a release version to release to your customers. You wanted to have a release version for your customers, but then at the same time you're developing at the same time. So you had to have different versions of the code, and how do you keep track of that, right? So what they've developed is that you've got the master, which is what the customer sees, or the final version of the code. So see how there's different tags, and they're pretty much releases, right? So tag 0.1, 0.2, 1.0.
Like different
right?
versions. Yeah.
Yeah. So when you have like patches and all that of software, and you've got different versions of Microsoft and all that. In the backend, they basically have something like this, where that version is on their master branch, but you've got other versions where they're working on that code in the backend, right? So now you've got the master, but then you've also got like a version of that in develop, and these nodes are basically what you call commits. So just think of this whole these lines as a whole timeline, right? And say each of the nodes are every time you push a code on the remote repository. So you're going to have two versions of the repository. The one version is on the remote, where it's stored in the cloud somewhere, and that's where there's a central version where people can access, right? But you also have a local version on your device where you can work on it, work on it just locally on your device without affecting the remote repository. Because if you work on the remote repository and you change that, right, then you could affect someone else's version of the code. So what happens is that you pull the code from the remote repository and you start working on it on your local device. And then when you finish working on it and you finish testing and all that, then you push the code from your device to the remote, right? And that's when the remote gets your version of the code, and then other people might have older versions of the remote repository. So whenever they want to sort of add their code to the centralized repository, then they will have to pull the code from the from the remote repository, right? So I'll explain more about that later, but in this case, so you've got the development branch, and then that's where you do that's where what the high level of the development of the company, right? That's where all the development sort of goes to, and then if say you're working on a specific feature, then you create a separate branch for that, and you pull the code from the development. So essentially what this is doing, so you're at this point, right, you're creating a copy of the code at that node, and then you're pulling it to this feature branch, and then now you're making changes on that feature branch, and now on that feature branch, the version of the code is much different than what you see on the development branch. But once you finish working on the feature branch, then you merge it back into development, and other people at the same time may have created different versions of the code while you were working on the code, right? So there's going to be what you call it, there's best practices to, working on code, and essentially it's good to separate concerns and separate what you're working on. So if someone's working on, say, one class or one object or one section of the code, you need to be working on another section of the code so that your code doesn't conflict, right? But if there's a case where you have to work on the same section of the code, and then your version of the code is different than their version of the code, then once you sort of merge the two branches together, there's going to be called what you call a merge conflict. And when there's a merge conflict, Git creates another file that has both versions, and it annotates which version is which, right? And it asks you to choose which part of the code you want to replace in those lines. So if you actually wanted, say, if you've got two team members that are working on the code and they have two different versions of that section of the code, that those couple of lines, and then say team member one, you didn't want to use his code, but you wanted to use team member two's version of the code, then you just select the team member two's version of that code when you're resolving that merge conflict, right? And then once you resolve that merge conflict, it creates another commit. So there's different ways, there's different methods of actually setting this up. So sometimes what you can have in a company is that instead of having this setup where you have feature branches development and release branches and hotfixes, right? Sometimes you just have one trunk and then everyone works in that trunk. And having a trunk is usually good for CI/CD, where everyone just works on one branch and everyone just commits to one branch, and they use feature toggles. They use feature toggles to enable features and disable features so that it doesn't interfere with the whole program, right? So you could do it that way as well, because that actually simplifies everything, and it forces people to sort of continuously integrate code with the code base. So that's one methodology. This is another methodology if you sort of want to modularize, or if you want to have separate feature branches for separate things. So that's sort of the basic theory on top of Git, right? Now, let me just go to the cheat sheet, and essentially you're going to forget, the commands, right? Because there's so many commands, so many unique ways of using Git. You could use, the IDE. You can download an app that actually, I forgot the name of the app, but you can use that to visually see, the branches and how everything fits together. But a lot of programmers just end up using console once they get used to it, because it's easy just to type in, commands to, update the repository. So here you've got, say, so you've got the basics. We've got git stash, git add, git reset, git diff, git commit, and you'll see me using this as I go through, the tutorial.
Mm-hmm.
Yeah. So that's just for reference. Okay. So I think a good practice, like I was looking around before to see what projects to use for this tutorial, for us to practice using version control. So I chose this one. So essentially it's just a counter. So it's a React.js app. And then if you actually go to the actual app, then so it's just the front end app that you can just start counting numbers on, and then you can remove, subtract, refresh, or and then see how this cart object or cart image updates. So we're probably I just wanted to sort of make a simple example where, say for example, we have the app and our requirements says add extra counters, change colors of counters, change fonts of counters. So before we start anything, I was thinking maybe I might show you sort of like Jira, right? So if say you got a requirement from, and this is like the Jira board. Let me just dual screen that, so, or yeah, split the screen, so it's easy to see. So yeah, usually you would have like requirements from the client, and I'm skipping a lot of steps, but usually at this point you would have broken down the requirements, and you would have, you know, an SRS software requirement specification document, and then you'd have user stories, and then you would split those user stories into like, you know, features and what you need to implement, right? Now, the way you track that when you're coding is that depending on how it's set up, if you're doing Scrum, or if you're doing, in this case, the Jira board is set up as Scrum, so that's agile, and you have sprints. But you could be doing this in you know, Kanban if you wanted to. Kanban is usually better for, you know, CI/CD. If you're sort of updating it continuously, like the code continuously. But if you have like milestones, then you can be using sprints. Okay. So I just made a test one, but I'll just say I'll delete this. But let's say that, yeah, we've got the requirements already, and then just say, you know, add extra counters, change color of the counters, change font of counters. So create issue, add extra counters, and then change colors of counters, and then change fonts of counters, right? And you know how it has, you know, a key here? It says BBDT-7, and then BBDT-8, and then BBDT-9. Now, yeah, if you weren't using something like this, and you created, you know how I was talking about the feature branches? So yeah, the feature branches. If you didn't use an issue tracking tool, and you know, it's just a local small project that you're working on, then you can have your own convention. But usually in bigger companies, what they have is they have an issue tracking, and it automatically generates, you know, unique identifier for each of the issues. And the way you can easily track it within your code is if you name the feature branches as your the issue identifiers. So let's go back. So here you can integrate it with the code, but we haven't actually created a repository. So I think that's what we need to do next. But yeah, so before I do that, I'll set up, we need to have a server to deploy the code, right? So before we even create a repository, let's go over to, and I've decided to use DigitalOcean. So I already have droplets open, but a droplet is basically just a server instance, and with DigitalOcean you can easily just spool up another droplet. So I'll just create one, and then let's call it, say, let's choose Ubuntu basic, and no, I'll just use a really simple, so lightweight. So let's go with Singapore because that's probably closer to us, right? Because we're in Australia. Yeah. Yep. Now you can put SSH keys and you could also put passwords and all that. But I'll show you how to do SSH key. Yeah. So at the moment, my computer is already connected to this droplet because my account already has the SSH key on this on DigitalOcean.
Mm-hmm.
But I'll actually show you how to do that. Say you can create a new key and then add in your new key, but I'll show you how to actually create it later in a future step. But in this case, if you already have your SSH key on hand, your public key, then you just copy it there, and you should be able to remotely access the server if you're using SSH from console, right? Yeah, and then so let's create the droplet. So it just has a random name, but we could have named it differently. So let's just wait until that finishes. Now, while it's actually being created, let's go back to say let's go back and actually open up Bitbucket, because Bitbucket is a part of the Atlassian product suite, so you can actually integrate it. And I already have an account for Bitbucket, but I haven't created a repository. So see how it's linked Bitbucket dev, right? But I still need to create a repository. And let's just call this tutorial. Right. Project name. Tutorial. This private repository. So if it's public, then other people can search up this repository and they can also pull your code. If you give it public access, but if you only limit, say people to download the code if they have the credentials uploaded, then they can still view it publicly, but they can't pull the code, right? But then if it's a private repository, then they can't. They're not able to view the actual repository outside. So I'll just go yes. Yes. So create repository, and this is just going to be an empty repo. So usually it comes with a README, and this is where you can add in your details for the projects. You can forgot what MD stands for, but yeah, markdown file. So essentially you'd have to create documentation for your code. So instructions on how to use your code, how to deploy it, and all that instructions. The DigitalOcean would have been finished by now. Yeah. So let's go into there. And now we have an IP address, right?
Yeah.
And I have a console ready, but let's see, because remember when I was creating this, this server instance, it was asking me if I wanted to use my SSH key, and I already had my SSH key on my account. So all I have to do is SSH and then copy this IP address. Actually, oh, right. So in this case, I can so at the moment, so when you spool up the instance, on DigitalOcean, you have a default account on the Linux server, which is root, but you can create your own other, other accounts after. Since we're just using this for tutorial, I'll just leave it as root, right?
Yeah.
Because there's nothing really sensitive on this server anyway. Now we have a server, and then now we also have a repo that's created, right? So, yep. Now, what you need to do, right, is you need to check if you have Vim. So, Vim is essentially a, file editing application on Linux, and it allows you to edit files on the console, right? So, what we can do, right, is start. We'll see if Vim still exists or exists on the actual. Yeah, so it looks like it does exist, right? So I'm just going to make, say, right. So I just made a text file, right? And then if I did vim test text, then I've now opened the file.
Yeah.
And then if I go insert, and then I write down testing vim is working, and then escape, and then save. Oh. And then now I'm checking if I'm checking the contents of the text file that I created. So it says test vim is working. So we know that vim is working now, and it means we don't have to install vim. But if it's bare bones and doesn't have vim, then you probably just install vim. Now we have to figure out if Git isn't installed on the server. So to check how to see if Git is on the server, we go Git version, right? So Git exists, so we don't have to install Git. But if it didn't exist, then you would have to just go through this instructions to install Git, right? So now, since we've created this repository, so let's go source. Let's go back to source. So what we want to do is we want to clone this. So clone, there's two ways to clone it. There's either you do it through HTTPS, and this is the method that you use if you're going to use a password, right? But if you're going to use SSH keys, then you just use this, right? So this is where I'll show you how to make it an SSH key, because it's more secure if you use SSH keys. Because the thing is, people can brute force long passwords, and they might be able to break and hack your password. But if you use a SSH key, then yeah, I could explain that in another video, but it's much more secure than just using passwords alone. So before we actually clone using this, right? This repository or your account, the Bitbucket account has to have the SSH key of the server, because this server is trying to access the repository from Bitbucket, but because this is a private repository, it's not going to give me access, because it's going to say permission denied. So I'll show you what it looks like if you try to do. So if I try to clone this, copy it, and then I'll put it on cmdir, and then paste it, and then enter cloning, and then I say yes. It says Fatal could not read from remote repository. Please make sure that you have correct access rights and repository exists. So
Okay.
it exists, but we don't have access rights because this is a private repository, but we don't have our SSH key. So the first thing you need to do is, so you'd need to check if your server has an SSH key in the first place. So it's usually in a hidden folder. So in Linux, usually when you write the command ls, it shows all the files that are not hidden. But if you go la, it shows the files that are hidden and the files that are not hidden, because it shows everything. But to tell if a file is hidden, it has a dot in the front of the file. So in this case, what we're looking for is .ssh, because that's the folder where the SSH public and private key is. Now, in this case, it's hidden. So what you want to do is you want to navigate to the SSH folder, and then you check that folder. It has authorized keys, known hosts, but it doesn't have SSH keys. So it has, keys that are authorized to access the server, right? Of this server, right? So it has the key of my laptop, which I'm recording this video, to be able to access the DigitalOcean droplet server, but it doesn't have its own SSH key. So now the next step we have to do, right, is create an SSH key from remote access. Right, so let's just go to the instructions for that. Yeah, so the simplest way, there's multiple ways of actually doing, creating SSH keys, but the simplest way would just be h key gen, and then you just create it. So generating file, enter file in which to save the key, and if you just leave it blank, then it saves it by default in your root.ssh ID RSA, right? So that's the default location. And the thing is, what you can possibly do is also put a password on your SSH key, so it's even more secure because you have to write in the password just to use that public key and private key pair. But in this case, the SSH key is enough for us to do the demonstration, so you don't have to put a password. And yeah, now the key has been generated. So if we type in, because we're still in the .ssh folder, right? So we're still in the hidden folder. So type in ls to view and see how now you have ID underscore RSA, and then you've got ID underscore RSA.pub. You don't want to give out this ID underscore RSA, right? Because that file is your private key, and the ID underscore RSA.pub is your public key. The public key is the one that you want to copy onto, onto Git, right? Or sorry, onto Bitbucket, so that it can cross-check between your device private key, and what it does is, it verifies, is this public key the pair of your private key, right? So you have the private key on your device that's trying to access the remote repository or the remote server, and then the public key is what you give out to the remote repository or the remote server, so that they can sort of do like a handshake and figure out, am I allowed authorization to this this server or this repository? So what you want to do is you want to see the content in ID RSA.pub. So you just go cat ID RSA.pub, and you get like this really long string, this key. Now what you want to do, right, is you want to add it into this repository. So you go to repository settings, and then you go into access keys. Yeah. So here it says use access keys to gain read-only access to this repository using SSH key. So add key, say Digital Ocean drop tutorial. Yep. And then you copy this key. Yeah. So notice that I'm using the console on my local computer, but I'm actually accessing DigitalOcean droplet from my local computer. And this SSH key is not the SSH key of my local computer, but it's the SSH key of the droplet on DigitalOcean, right? So I add the key, and then it adds. Okay, so now I should be able to go back to the upper level. Now let's try that again. Let's now go back to back, and let's clone it again and see if this works now. So it should in theory work. So it says cloning into tutorial, and see now it doesn't have any permission issues. So if I go ls, now I have a folder called tutorial. So cd. So this is a common mistake, right? So people clone repositories and they start working on things, and then when they write down git status or git command, right? It says fatal, not a git repository or any of the parent directories .git, right? Reason being is because the repository is in that folder. It's not on the folder that you currently are on. So you have to navigate to this subfolder tutorial, because that's the actual repo, right? So now since I wrote git status, it says you're on branch master. Your branch is up to date with origin master, nothing to commit. Now, remember how when we generated this repository, there's a README file and Git Ignore, right? The README file is there, but if I go, if I type in LA, it says git ignore readme.md. Now, best not to touch the .git, because that stores the settings of the actual version control. So if you modify you can modify some of the files in there, but yeah, you have to know what you're doing. But mostly you can modify git ignore and readme.md. So I didn't explain much about what git ignore is. So git ignore is the file where, because you're sharing files with other team members, sometimes you have large files that are generated when you're, say, building the code, when you're testing the code and all that. And when it's running on your local computer, it consumes a lot of memory, right? So you're not going to push those files onto the server, because that's just too much memory usage, right? So the code that you're writing on, so like the say if you're updating a PHP code, right, or if you're updating JavaScript, right, you only need to version control the JavaScript file. You don't need to version control, say, in Node.js, you have libraries, you've got modules, libraries, and all that. You don't have to version control that, because those libraries are already public online, and you can just initialize, right, the project when you download that on another device, or you can just pull the libraries on another device anyways. So you don't need to version control the libraries, and that's where you write in git ignore to ignore specific files, so the repository doesn't become bloated, right? So let's just look at what Git Ignore has. So in this case, it's ignoring the node modules, So those are the libraries for like Node.js, and then it's ignoring specific files like exe files, MP4 files, and all that. So these are the files. These assets are fairly large, right? So if you wanted to have a version of these files, or if you wanted to save them somewhere, then you would probably have a different area to save them on. And then the code that you're actually updating is what is stored on the repository, right? Okay, so it's all set up. So now what we can do, right, is let's set up the, so the projects. So our repository is located on Bitbucket, but this app, right, this project that we're going to work with, right, is on GitHub. So there's different providers, different companies that have their own flavor of Git. So it really depends on the company that you're working for, the stacks that they're using, the technologies that they're using. But yeah, in this case, like you can use different platforms if you want. So sometimes you might have code coming from GitHub, sometimes you might have code coming from Bitbucket, sometimes you might have code coming from GitLab, etc., etc. But it is possible to sort of combine them together if you wanted to. So I'd copy this because there's probably no password for this repository because it's public, right? Now let's go back to here, and then so see when I copied it, it doesn't actually have in Bitbucket it has the whole script. So when I press that in Bitbucket it says git clone and the actual the address of that repository. GitHub doesn't actually it doesn't show it, right? So what you have to do is you actually have to just type it in manually. So git clone, and then it clones. Yeah. So git status. So let me just go through the syntax, right? So let's go back here. Yeah. So okay, I've lost. Yeah, okay, so Git status shows you, shows you the modified files in the working directory. So let me just zoom in here so you can actually see. So see how when I wrote git status, you see how this is red? If it's red, it means that the code isn't staged, right? So I'll have to open up another documentation to explaining what is staging, what is unstaged, and all that. So just okay. So I'll just look at this image here. So your working directory, right, is your local device, right? And you can make changes, do different things, right? But it's not going to affect the remote repository. Now, there might be some parts of the code where you're still working on and you don't want to push to the remote repository, but there might be some files or some code that you finalized and you want to put on the remote repository. So that's where you stage it, and you would run the command called Git Add, right? So Git Add adds files as it looks now to your next commit, right? Now, the reason why this the files that we just added is color red is because it's currently unstaged, which means it's still on your working directory, right? But you haven't actually staged it yet, or you haven't actually added that, right? So that's why it's red, right? Which means you can change it all you want, and it's not going to affect the remote repository, right? Now, if you want to add the file, then you go git add, and then after that, when you want to commit the file, when you commit it, that is not committing to the remote repository. That's committing it on your device, right? So you commit.
Yeah.
So you commit the code on your device, and essentially that updates your local version of your repository and says, oh, this is a new commit. This is now the up-to-date code, right, of the your local repo, right? Now, when you want your version of your code to be the same as the remote, then that's when you push it. So you run the command git push, and that will either. So if you push before you pull the code from the remote, what will happen is if you were working on some code, and then you're changing someone else's code, right? And then there's a different version on the remote, then you're going to have a merge conflict on the remote, right? But then if you pull, right, and then you sort of commit, then you'll have a merge conflict on your end, which you need to resolve, right? So the best thing to do first is, what you need to do is pull the code first, so that you have the most up-to-date code from the remote repository, and then you commit your code on top of that, so that you know that there's no merge conflicts because you have the most up-to-date and no one has changed it since. And then you commit your code on top of that, and then you push your code. And when you push your code at that instance, you know that no one has changed it, because you sort of pulled the code before you pushed the code, right? So it's a good practice to always, before you're pushing the code to the remote repository, you always pull the code to see if you have the most up-to-date local repository to the remote repository, right? And that will reduce the amount of merge conflicts that you have. But that won't always remove all the merge conflicts, because there's some cases where you might have merge conflicts when you're, say, merging branches together, and you have to resolve them in the future anyway. Because when you're integrating code anyway, at some points there are going to be merge conflicts. And that's the reason why you have separate branches and modular code, so that you limit the amount of conflicts. Because if you have modular code, then you're always working on separate parts of the code, right? If you're having a monolithic piece of code, everything's together, then you're always going to have merge conflicts, because your version of the code is always going to be different than someone's version of the code of the same file, or of the same part of the code. Okay, so let's move on. So as I was talking before, so git add. Now, if you do git add dot, what that does is it adds all the files that are red, right? If you had separate files, so for example, let's go into hold on. Oh, that's another thing as well. So you know how I did git status, right? And then now it says it says on branch, your branch is up to date with origin master. And you may be asking, oh, why was this branch not up to date, and then now it is up to date? And the reason for that is because when you actually went inside the counter app, right, that's actually a different repository. So you're working on a repository inside a repository, right? So sometimes you can work on nested repositories and all that kind of stuff, but you just have to be careful of, are you working on your repository or are you working on someone else's repository that you cloned inside your project, right? So that's when it becomes confusing. And yeah, so in this case, I can't show you because usually, or what I can do is this, right? So let's say I make a separate file and call it test.txt, right? ls. Now I'll go git status, right? So in this case, yeah, now you see both of them are red because both of them are modified on my local device, but I haven't staged them yet. So if I wanted to stage all of them, then I could go git add, right? But I'll show you what it looks like when I go just stage one file at a time. So if I go git add, say, I'll do the counter app. Yeah, so it says you've added another Git repository inside your current repository. Clones of the outer repository will not contain the contents of embedded repository and will not know how to obtain it. Actually, what I'll do, right? Yeah, so I'm just trying to, and that's another thing. If you're stuck in the middle of something, it's good to look at forums. Yeah, so it says just delete the git.git directory and it will be all. So if I just went into the counter app, right, and then ls and then la, see how it has .git. If I just go rm rf.git, so rm.rf is just a command to delete, files. So rm is to delete the file, but then -rf is to recursively delete the files inside that folder. So in this case, we want to delete so ls. So if I go git status, yeah, so see how there's, yeah, it no longer says, hold on. Yeah, it no longer has this this message, right? Because when I deleted that .git, it deleted the the repository or the reference to the repo of the counter app, and now it's referencing the parent repository, which is the one that we made. So if I go back out, right, I go git status. Yeah, so yeah. Okay, so let's just do this for instance. So git so what I just did then, right, was if you accidentally staged a file and you wanted to unstage it because you wanted to add changes to it before you commit, you can just run the command that that it mentions to unstage, and then now it's unstage. But let's try git add all. So if I did git add all, then git status. See, now it's added the whole thing, right? And notice how it doesn't give me hint warning anymore because I've deleted the actual repository of the the nested repository. Yeah. So it's just normal files now. So going back to that diagram, so we've added now we just need to, to commit. So this is the command that you usually run. So where is git commit? Yeah, so git commit -m. So git commit -m, and you add a message. You describe the message. So you describe what you did. So git commit -m, created a new counter project. Right. So you press enter. And yeah, at the moment, because when I wrote down git commit, it didn't do anything. So if I go git status, or actually git log shows you, if you go git log, right, it shows you the commits. So initial commit was made by when you generated the repository, and all the branches are currently at the initial commit, right? But in this case, it doesn't know who I am, right? So it can't access this repository. So yeah, so I have to add my credentials. So in this case, so I'm just going to test something. Because I've used my email, but remember how I had the SSH key? So if I have my email and I have the SSH key, then it should be able to commit. Yeah, so there you go. Because I have my email, now it knows whose account I'm using, right? And then when I ran the commit message again, it was able to create it because now it has reference. If you did the HTTPS, right, then it would ask you, please enter your credentials or please enter a password every single time, right? Unless you actually do git config global and then user.password equals this, right? And then it would automatically, use your password. The only downside is if someone also has access to your server, they could easily just look at your global configs and see what your user password is, right? So that's the one reason why you have the SSH key, so that they kind of have access to it, even though they don't have the if they don't have the SSH keys, right? So ls git status, and then now it says on branch master, your branch is ahead of origin master by one commit, right? So because we know that no one has worked on the master branch and no one has made any changes and all that, we don't have to pull from the master because we're the only ones using this project, right? So what I can do is now I can go so git push. So push. Okay, so it says okay, so right, that's another thing. So sometimes this happens because remember how now I'm able to pull the code, but why can't I push the code, right? And do you know why?
Why? Yeah.
Because let's go back to access keys, right? Remember, this is only read only. So for security reasons, you can't modify this SSH key. So access key can only gain read-only. So this is only read-only access key, but I think what we'll have to do is so probably have to go to the, personal settings, right? And then actually, so you would have to actually go to the personal settings Bitbucket, right? And go to SSH keys. And so the access keys only gives you read-only access. This one gives you read and write. So when you add the key, let's go back up and recopy this key, right? So add key. So tutorial, add key. Someone has already, so you'd have to change. So someone has already added that key as an access key to a repository. So in that case, we'd have to go back and we'd have to delete it. So let's go back. Let's go to repository settings, access key, and delete, because or else we can't put the SSH key. Personal settings, SSH key, and key, paste, motion, droplet tutorial, and then add key. Now we have, so this should have read and write access, right? So if we go back to here, the console, it should give us the ability to push. Let's see if this works. Yep, it's working. It's working. Yep. So when you go Git Status, now on branch, your branch is up to date with the origin master. So let's look at the repository here now. So now, see, now this appears. Actually, sorry, that is the repository, sorry. But see how now we have an extra folder, counter app, and we also have that test text. So now this is on the repo, right? Like our tutorial repo, right? And you can spool up another server instance and then pull this code on another server instance. Or you can have a local device, have it set up locally. You can have a VM, a virtual machine on your device, and then work on it locally, and then have the same thing happening, and then people can work on different things, right? Okay, so that is that.